Alright, this video is about finding the hypothesis test for a one population mean. The scenario that we're going to work on is that the assembly of all four torus take about 38 hours, so that's mu, with a standard deviation of 1.2 hours, sigma. A sample of 47, there's our n, of assembly times of the four toruses ended up being 37.5 hours. We want to test at the 1% significance level whether the time has decreased. Alright, so there's 6 steps. We know that we're going to be using a z-test because we know the population standard deviation. The first step is to state your null and your alternative. The null is always what they say the mean is. They say the mean is 38. So mu equals 38. The alternative is what we're trying to test. Remember, I just said, has the time decreased? So that means mu is less than 38. Second step, just to restate our significance level. Alpha is 0.01. Third step, that's where we get our test statistic. All that is, because this is a z-test, is our z-score. The z-score is our x-bar, 37.5, minus the mean, 38, divided by sigma, 1.2, all divided by the square root of n, which is 47. Remember that this can be found in your pullout under Chapter 9. Alright, so when we calculate this, remember to 2 decimal places, the z-score is to 2 decimal places, we get negative 2.86. Fourth step, we're going to be doing the critical value approach. Critical value approach says, well, what type of tail test is this? Remember, we find the type of tail test by looking at our alternative. It's a less than, so it's a left tail test. Alright, so it's a left tail test, and we need to know our rejection region. That's the rejection is to the left. Well, the rejection region is our significance level. So in this case, it's 0.01. Alright, so we're going to look on our z-table, in the body of our z-table, for the number closest to 0.01. Also, remember there's that little bitty rectangle underneath the t-table that has the common ones, and this is a common one. It has, if you look, a z-score of 2.326. We're doing a left-tailed test, so that means it's got to be negative. Alright, now we're ready for step 5. Step 5 says, based on our step 3, does it fall in the rejection region or the non-rejection region? Well, we can look. Negative 2.86 is actually below negative 2.3. So it would fall in the rejection region. So our decision then is to reject. Since we rejected using the critical value approach, usually you'll have 2 sentences. The first one says, yes, we have enough evidence to say that the time has changed. It's different than 38. The second sentence will tell us if it's less than or greater than. At the, and we state our significance level, 1% significance level, the data do provide sufficient evidence to conclude that the mean population, which is a variable, time to assemble all 4 toruses, that was our population, toruses, I guess this is it, differs from 38 hours. So it's just different from. Now we want to put Well, we know it's different, but is it less than or greater than? Well, based on our z-score, our test statistic, number 3, we see that we have a negative z-score. Anytime you have negative, that means it's significantly lower than the mean. If it was a positive z-score, that means it would be significantly above the mean. So this means it's less than the average. So the second sentence says we are 99%. And it's 99% because we know we're 1% significance level, so that means we're 99% confident that the mean time to assemble all toruses is less than 38 hours. And that concludes the critical value z-test for a one population mean.